Thank you very much. It's great to be here. I had a little adventure with my flight, but I'm here on time. So this is awesome. And thank you for coming over to my talk, Unlocking Cyber Insights with AI using machine learning, LLMs. This talk is longer than my name. So let's get to what I'm going to talk about. I'm going to be discussing about AI for cybersecurity, how we data scientists can help practitioners. And then I'm going to be getting to the fundamentals of what we do, which is exploration of data, exploratory data analysis. That's the EDA part, and how we can apply this to explore security data. And finally, an interesting application for cybersecurity that we can do with AI, and that is classification. This talk is for, you could think that, okay, I'm a data scientist, it's for data scientists, but my heart is a cyber CTF person. I can't wait to do the CTF. So it's also for analysts that want to decipher their data as a black box. And I think that you're gonna find that AI can help you maybe as a pair programmer or maybe even as a detector of maliciousness. So let's dive into that. This is a little bit also the story of my life. I like to make that joke. I was in academia, and then I went to industry. And while I was in academia, I loved math. So I was doing a lot of statistics and all that. That was my PhD. And then I would do lectures, and nobody would get in the class. And then we put a frame, and we called it ML, and we had more people. And then we called it AI. And that was it. I mean, it became very popular. So, but it's really math. Anyway, let's get to the applications of AI in cybersecurity. So we're fortunate, and that's why I love this field. We're very fortunate to have a lot of diverse sources that give us data. And that could be the network, that could be the edge. We have mobile devices that have their own quirkiness, and we have many generators of data. And then we also have different types of data in cyber. We have unstructured, which is a little bit of a nightmare for the data scientists, but it's still good data, good information. And we have structured data, and we have network logs, literally looking at the wire of packet traffic. And then we have sources that you may not think about, like, when you do fuzz testing, for example, that could be very interesting data for somebody like me, because I can look at, the patterns behind the tests, or, things that we can read through, or even, how you decide to test something. So as data people, we have to organize our data and, of course, collect it. So that's what is shown is over here. And then there's a rich set of applications for AI and cybersecurity. Definitely, we can recognize patterns. Anomaly detection is a great application in this case. We can also predict the future, forecasting, and say, let's say in Christmas, there's usually a pattern of more maliciousness because people try to spend some time away from the SOC. So these are the predictions that we can make, and less obvious predictions like that. It's just a good example. And then we can also make decisions like, is this malware or not? Is this malicious or not? So decision making is great. And one of my favorite applications of AI for cybersecurity is automating the boring things. So we really love doing that for our analysts at Expel, to give them, time to do the creative things. So I'm like, if I can automate something boring, I'm happy. My life is good. Lastly, there's testing that AI can do for cyber applications, and that's pen testing. So super interesting stuff and very cool applications. So now I'm going to get back to that little thing of statistics versus AI. So AI for cyber, and we have a lot of different talks here. I've seen some predictive talks and all that. So the traditional ML was called predictive, and it was more about being able to find, let's say, boundaries between two classes and all that, and classify good from bad, malicious, or multi-class classification that could be ranking, high, medium, low. So these models, the predictive models, the traditional models, are very good at this type of thing, but they cannot generate data. And now, 2.5 years ago, we have this huge revolution of generative models, and everybody loves AI and all these things. So generative models can definitely generate data. They can generate text and other more rich types of data, like pictures and all that. However, they are not as good as predicting or classifying. They were not made for that, actually. So in this talk, though, I would like to ask the intriguing question, were they? Have you checked? So maybe they are for some applications. So yes, so that's the last part of AI for cyber and how we can help. Now let's go to EDA, exploratory data analysis. So this is a thing that we spend most of the time, our time on as data people, and also I would say analysts spend a lot of time getting the data they need, analyzing the data they need, cyber analysts. And we do it with two main ways. One is visualizing the data, and the other one is statistics. Visualizations can be great. They are an art and a science, and they can be misleading too. So one needs to tread carefully over there. Scatter plot could show some correlation that is not there. And then statistics can also be manipulated, like, if you divide not with all the population, but with something less or more, you can skew even your statistics, even your math. So there's that. But this method is established for decades now. NIST has a whole manual, if you want to check that out. It's the same as it was 30 years ago, and a very 80s type of manual that has, the concepts, though, are good, and they are, classics. So statistics and visualizations equals EDA, and it's a well-established method for exploring our data. Now, why do we do EDA, and why do we spend, I would say, 3/4 of our time as data people? And again, I think analysts spend a lot of time looking at data. Why do we do it? Well, data is messy. It wasn't how it was when I was doing my academic homework assignments. It's very, unclean and a mess. And also, besides that, we want to know our data better as in a data science setting. We want to be able to characterize our data with features and then do some really good modeling. And that's going to be done only if we understand it very well. And also there's questions that EDA can answer and also that it cannot answer. So is the data accessible? Okay, that's more a data engineering thing, but is it usable? Can we actually use it, or is it junk? Can we understand it, or is it maybe a language that we cannot understand, Greek? So is it sizable? Does it have enough? Do we have enough that we can do something? So that's what exploration can show us. So why do we use EDA for cybersecurity data now? Cybersecurity data, I have to say, is also messy. We didn't have the luck to have the cleanest data in the field. It's unstructured. And it's also, many times, it's a black box. We have no idea what we're looking at. We're like, is this an attack? Is this something else? So, and we don't have good ground truth. What if it's a 0 day? So there's that. On the other hand, the application of cybersecurity, and when we start using the ML and the AI, the application is very critical, okay? So we're talking about people's livelihoods, whole companies. I mean, we are doing something important, so we have to be able to explain it. We have to be able to be robust, and that's why we need to understand our data and explore it really well. And finally, raw cybersecurity data, and I'm sure there's a lot of cyber analysts here. It's not normalized. So I think you know that, we all know that. We have to do a lot of normalization to standardize it, to make it better. And it's also unstructured, lots of logs and all that that can have great information. Okay, so I picked maybe the worst data set for this application. However, I have done a lot of research in network detection. I'm doing here now managed detection. We have more rich data. But I was like, let's challenge AI with a data set that is really very not for the application. So it's a packet capture, which is really reading packets on the wire. I'm showing here Wireshark. It does look like a spreadsheet. So to a data person, it would be like, yeah, there's columns. So it definitely looks like a spreadsheet. However, there is not much text. There's IPs, there's numbers that are text. So, you know, it's a very mixed data set. The payload many times is encrypted in packet captures. So not a great data set, but we have to look at it and we have to write the detections and all that. So this tool, the Swiss, what is it called? The Swiss Army knife of reading packet captures also have some really nice data that a data scientist would never think about using, like the hexadecimal part that I'm showing at the last part. So I picked this data set for a challenge to answer some questions, and then decided, let's have something that looks like a benchmark. So how many of you have heard of the Mirai botnet? It took the internet down, quote unquote, a few years ago. Not really, I mean, but it took advantage of vulnerabilities of Internet of Things devices and then attacked DNS servers. And then we thought Reddit was down, which it wasn't. It was the DNS. But it's a very characteristic one. And we have good data on these from ISPs. So I think this could be a good benchmark for this type of application. And then benign network activity, I had a very rough time. So, and I'm open sourcing everything, so you'll see my sources at the end. I had a very rough time to find benign network activity because you have to shut your network to be sure there's no bad guys, but then if you shut it, it's not normal behavior, right? It's not your regular. So there was a great data set from an Australian research university, and I've used that. I think they've done a really good job. And now to the choice of language models, the AI for exploratory data analysis. We tried to do a little bit of a mixture of language models, and there's more. I mean, as I was doing that research, I thought about other things. But first, I wanted to have large and small models, because the small models, you can even run them on your laptop with Olama and all that. So the three last ones are smaller. And let's challenge them and see what they can do, because they're pretty smart sometimes. And then encoder, decoder, there I didn't strike the balance that I wanted, and I thought about it too late. So I thought about decoder models because they generate. So I was thinking we can have AI as a pair programmer to generate good conclusions. But then the encoder models can do better classification. So there's that. So that's a hypothesis, at least. Finally, both encoder decoder are the chat models that can understand and produce. And then the reasoning, you've heard it once or twice, DeepSeek can reason, or everybody can reason now. So the reasoning was iffy about a couple of models, so I wanted to test that. Okay, so here, what we started with was, okay, take the packet captures. They're not in a format that you can use for this type of application. So convert them to a spreadsheet or a pandas data frame. So that was the first thing, make your data, and maybe that's most of the code that I wrote for this application, because again, you have to have your data in a presentable manner. Then the rest of it was traditional descriptive statistics that very nicely even if you're not a data scientist, and I've shown, and I have parts of the code here, are one-liners. So you can do descriptive statistics with .describe if you have a data frame. So they're very easy. So I'm saying that the barrier can be for anyone that is not a data science person also, that they want to look at data and have some good deductions. And then finally, the prompt is an art and the science as well. We put some work on the prompt, a bunch of models. We get the result, which is really something like a report. So the model says, I observe these things based on your statistics, based on your functions, based on that. How do you evaluate something like this? It's a pickle. So there is some really cool research, actually, and we use this a lot, actually, in our team, using another language model as a judge of the text, giving it instructions and all that, and we call that LLM as a judge. So that is super cool because it can give you qualitative and quantitative results. And it's awesome. I think you're going to really enjoy the results. Now, I'm showing a little code here so that you can see what that prompt is. And it's not very long. It could be longer and all that, but there's data behind it. So there's the descriptive statistics that are behind it. So then there's that. And then I have some other functions. So besides statistics, I wanted to do a little bit of t-test, which is for testing a hypothesis, is something correlated to something else. And that's the prompt for that, so hypothesis testing. And then I also did a z-score, which is for outliers, which is super useful if you want to see that something fishy is happening. It's outside of the profile of your data. So these were the 3 experiments. I did some visualizations, but I didn't evaluate those that much. And here are the results. Okay, so the results are interesting because there are qualitative results. So when you use LLM as a judge, it's going to produce text. Now, you need to use some ground truth. So because I had looked at this data a lot, I wrote a report. So there's a lot of, was that report good? Well, I will say it's good because I wrote it, but I have a lot of familiarity with this data set, and yet the metrics could change with your ground truth. So you see that the judge says that Gemini did pretty well, and it identified a lot of interesting potential exfiltration issues and stuff like that. And then these are the 3 smaller models. So I showed first the larger models, and this is how I have them in my graphs. Also, the 3 smaller models, they didn't do that bad, actually. And you'll see in the numbers also that they haven't done nearly as bad. And I will remind you that I was running these experiments on purpose on my laptop. I wanted to make a point because we have a lot of red tape to cut to use a model in general in security, right? We respect our clients' privacy. We need to do it responsibly. We have a lot of that in our team. And so I was like, if I want to use a model, I could use it on my computer and then prove that it's good, and then cut the red tape and ask IT to approve this for me and stuff like that. So that was the purpose, and I hope that this inspires more to use these models. And so here are some results, okay? So I only showed the qualitative results for statistics because there was a lot of talking from the LLM as a judge, but here are the quantitative results. So the LLM as a judge also gives a number. It judges how close you are, so it's a percentage. So you can see here, and again, the bigger models are the 3 top, and the smaller models are the 3 bottom. You can see that the chat model, the Gemini model, has outperformed for the most part. But then you see a decoder-only model like Palm beating it in the 3rd experiment for outlier detection. And then the smaller models, they're not doing that bad when you look at the Llama on the top part competing with Gemini, a much larger model and all that. So So yeah, so I think this is intriguing, and again, very much more can be done. So now, finally, the last application for this little comparison that we did is, can we predict with language models? Can we predict whether something is bad in the network or not? So we have traditional models, you would say, over here. We have k-means, clustering, we have all these great things. We have random forests. Why would we use language models? Well, because it's an interesting question, and maybe they will do well in some things. And I have some interesting results for you on that. So we classify a lot in cybersecurity. So I'm only showing network data, but we also do it a lot with the team, with emails, with spam, or we may classify to prioritize vulnerabilities. If you hadn't thought about that, this is that high, critical, high, medium, low. This is a multi-class classification. It's still a classification. Super useful in an MDR and for a SOC analyst. And then we also, of course, correlate events. We try to figure out if there's causation and if there's relation between things. So that's why we do it. I use one little piece for experimentation, the network data, but there's a lot more to experiment. And again, I went through the same workflow, convert the data to a data structure, then add labels that were not always necessary. So say this is a malicious set of streams and all that. This is a benign one, and then downsample. Because I had too much of one, too much of malicious data, and too little of benign, I downsampled for balance. And then, of course, the classification. The evaluation here is a little easier. Let's look a little more about the experiments. The experiments were interesting because now we have language models, and you may have heard few shot, one shot, zero shot prompting. So zero shot wouldn't give any example to the model. So throw it in the deep and see how well it does and what it can recognize without any examples. And then few shot gives examples, and of course there's the prompt. So this looks a lot like, again, a classic data scientist set of code where we pick a model, in this case, the zero shot model. We fit something. In this case, we don't train the model. We don't change it. We just tell it there's two labels, 0 and 1, malicious and benign. That's all we tell it. And then we try to predict and we measure what it does. And I said evaluation is easier, and I'm not lying. If you've been working on the SOC or in detection engineering, you know that we can count these things. That many true positives, that many false positives and all that. And we have some good metrics also. Accuracy is not the best metric. It's a little bit, crying wolf all the time. You can have 100% accuracy, but it's not a great model. But then we have precision and recall. So precision is about how many times that we cried wolf, we were actually right. Recall is the sensitivity, how sensitive we are, what we don't miss, which can be super important as well. And then we have a score that combines the two, that F1 score. So now, I think this is the most exciting part of this research because it opens a lot of horizons. So zero shot. Again, I have the 3 larger models with the same colors first, and then the 3 smaller models. These are the percentages of accuracy, precision, recall, and F1. So the groups are for the metrics. And you can see that, we're hovering in the 80+% in our best days with zero shot, but I wouldn't give this to our analysts and say, yeah, take off all the detections, use my model. So this is not good. We want to be in the 90s plus. However, 0 examples, okay? So that's something to think about. The few shot was interesting because I wasn't able to complete all the experiments. And particularly, I found that it was Gemini, Palm, and Gima that I wasn't able, and these are all three Google-based models. So I don't know if there was something like an infinite loop, but literally, you know, I tried everything. So these three were out of my results. I only had one large model, Mistral, and then Llama and Phi, which is, Phi is the Azure, I think, model. Pretty sure that's what it is. And you see some improvement here. We gave some examples to the model. It did pretty well. And there are a few examples. It doesn't have to be too many, very few examples. So finally, the really critical thing is the last chart, which is about comparing with the darkest column, which is a random forest. So you can see it defeats everything, the highest and all that. So is that the conclusion, though, that AI language models should not be used for classification? I wouldn't say so, because we have Phi in recall. So if you look at the third group, we have Phi that is close enough, is sensitive, as sensitive almost as the random forest. And let me share another secret with you about the random forest. It needs labeled data. Do we always have labeled data? Think about having your analysts labeling thousands, millions of packets, alerts, whatever. It's boring, it's horrible. So the models, the language models did pretty well with unlabeled data. So that's a good conclusion, I think, in this case. So now I'm wrapping up, and I'd love to hear questions, observations. So the takeaway, I see EDA with language models for cybersecurity as a buddy, like a pair programmer that can help us. We can discuss, and not always do I have a fellow data scientist or a fellow analyst to discuss. So maybe we can discuss with the models and exchange ideas, which we're doing already. However, now with data and some very structured techniques. Then classification, I think, is promising. I think it's promising for unlabeled data set, and we plan to do more research as a team, actually. And then LLM as a judge, I think it's a very exciting research point that everybody should be looking at. Finally, there's so much. You can fine-tune the models and make them better. You can experiment with different things. Like recently, I saw some research that people are experimenting with CTF data. So not only fuzzing data, but CTF data could be interesting to benchmark language models and say they're good enough at cracking passwords or something. So then we also have other ideas about using specialized embeddings for the models to make them better at understanding the lingo of cyber and being able to either recognize data or classify or do exploratory exploration. And then, of course, agents. I mean, you may have heard this once or twice. So I would love for you to try this, and especially the local models. You don't have to have a cloud account for those. So I have the code open sourced. And thank you very much for the time. And I think I have some time for questions, too.